Types of generative AI. The first one that we'll look at is Generative Adversarial Networks, GANs. Generative Adversarial Networks are a class of generative models introduced by Ian Goodfellow and his colleagues in 2014. GANs consist of two neural networks, a generator and a discriminator. The generator attempts to generate realistic data samples from random noise, which, while the discriminator aims to differentiate between the real data samples from the training set and fake samples generated by the generator. Through adversarial training, where the generator and discriminator compete against each other, GANs learn to generate increasingly realistic samples. GANs have been successfully applied to various tasks such as image generation, image to image translation, style transfer, and super resolution. Next, variational autoencoders or VAEs. VAEs are another type of generative model that learn to represent data in a lower dimensional latent space. VAEs consist of an encoder network that maps input data to a latent space representation and a decoder network that reconstructs the input data from the latent space representation. Unlike traditional autoencoders, VAEs learn a probabilistic distribution over the latent space, allowing for the generation of new samples by sampling from this distribution. VAEs are particularly useful for tasks such as image generation, data compression, and representational learning. Recurrent neural networks or RNNs and transformers. Recurrent neural networks and transformers are widely used architectures for sequence generation tasks such as text generation, music generation, and video frame prediction. RNNs, especially variants like long short term memory or LSTM and gated recurrent unit or GRU, are well suited for processing sequential data due to their ability to capture temporal dependencies. Transformers, on the other hand, rely on self attention mechanisms to capture global dependencies in the input sequence, making them highly parallelizable and efficient for long range sequence modeling. Both RNNs and transformers have been applied to various generative tasks, with transformers gaining popularity in recent years due to their superior performance and scalability. Each type of generative AI has its strengths and weaknesses, and the choice of model depends on the specific task and dataset characteristics. By understanding the principles and capabilities of different generative models, practitioners can choose the most appropriate approach for their applications and explore the rich possibilities of generative AI.